morning, all of you. How are you? Today, in this class, I am going to describe root mean square value of AC, which is taken from your chapter Alternating Current. Okay? What is root mean square value of AC? The value of direct current which produces the same heating effect in the given resistor as is produced by the given alternating current when passed through the same time is called root mean square value of AC. It is denoted by IRMS. Okay. IRMS, root mean square value of AC, is also known as effective value of AC. Okay. Now I am going to establish relation between IRMS and I naught. Relation between IRMS and I naught. IRMS, that means root mean square value of AC. I naught, that means peak value of AC. Okay. Let an alternating current passing through a circuit of resistance R. When some amount of current is passing through a circuit or conductor, then some amount of heat is produced. From Joule's law, obeying, if dH joule of heat is produced in the small time dt from Joule's law of heating, obeying here dH is equal to I square R dt. Here I is the instantaneous value of AC. Therefore, total heat produced in one complete cycle is, that means integrating both sides. Therefore, integration dH is equal to 0 to integration 0 to t I square R dt. Okay. This is also written as, that implies dH is equal to 0 to t. Here I is the instantaneous value of AC. And general form of AC is I naught sine omega t whole square into R dt. Okay. This integration cancel the sign of differentiation and hence only H remains. It will become I naught square sine square omega t R into dt. Therefore, H is equal to I naught square R. I naught square and R both constant terms and comes out from the sign of integration. Okay, 0 to t sine square omega t into dt. Okay, sine square omega t into dt. From the formula of trigonometry, here sine square omega t, since sine square omega t is equal to 1 minus cos 2 omega t upon 2 omega t upon 2. Now, I am putting the value of sine square omega t inside the sign of integration and solve it. That is, okay, therefore H is equal to H is equal to I naught square r upon 2 integration 0 to t 1 minus cos 2 omega t into cos 2 omega t into dt. Okay, 2 is also constant and comes out from the sign of integration. Therefore h is equal to here h is equal to I naught square r by 2. Okay, integration 0 to t 1 into dt minus integration 0 to t cos 2 omega t into dt. Okay, cos 2 omega t into dt. That implies h is equal to I naught square r by 2 integration dt 0 to t minus cos 2 omega t. When we integrated it, then it comes sin 2 omega t upon 2 omega 0 to t. Here lower limit is 0 and upper limit is t. Okay, limit is 0. That implies h is equal to I naught square r by 2 into t 0 to t minus 1 by 2 omega sin 2 omega t 0 to t. Okay, that implies h is equal to I naught square r by 2. This is the variable term, and in place of variable, first of all upper limit, and then after giving minus sign lower limit is placed. Similarly 1 by 2 omega sin 2 omega into t minus sin 2 omega into 0. Okay, that implies h is equal to I naught square r by 2 t minus 1 by 2 omega sin 2 into 2 pi by t into t minus sin 0. Okay, here omega is equal to 2 pi by t in the form of time period. That implies h is equal to I naught square r by 2 t minus 1 by 2 omega. This t cancelled this t, and it will become sin 4 pi minus sin 0. Okay, that implies h is equal to I naught square r by 2 t minus t minus h is equal to, here look here, that implies h is equal to I naught square r by 2 t minus 1 by 2 omega into 0 minus 0. Okay, 0 minus 0, because the value of sine 4 pi is 0 and the value of sine 0 is also 0. That implies h is equal to I naught square r by 2 t minus 0. Okay, that implies h is equal to I naught square r t by 2. This is the equation 1. Okay, now we assume that IRMS be the root mean square of AC. Then total heat produced in one complete cycle, produced in time t second. Okay, h is equal to IRMS square into RT in complete cycle. That means the time taken to complete one cycle of AC is called time period, and time period is denoted by capital T. Okay, from equation 1 and 2, from first and second, we have, okay, IRMS square RT is equal to I naught square RT upon 2. Okay, here RT cancelled this RT, that implies IRMS square is equal to I naught square by 2. Okay, that implies IRMS is equal to root I naught square by 2. Okay, that implies IRMS is equal to I naught by root 2. Okay, that implies after solving it, we found that 0.707 I naught. This is the required relation. This is the required relation. This is the required relation. That means IRMS, root mean square value of AC, is equal to the 0.707 times of peak value of AC. Okay, and hence we here able to establish relation between IRMS and I naught. Now in the next class I will teach you purely inductive circuit, capacitive circuit and inductive circuit and their combination. Till, thank you, have a nice day.